Hi, welcome back. So let's now review once again your calculus, and we will once again relate this in order for us to prove the formulas in our integration. Okay, so say we have a function of x is equal to x to the 4 plus 6. Okay, so to find its derivative, let's find its x prime of x, or we can just simply represent this f prime of x as f of x, small f of x. Then its derivative is just 4, then x, then 4 minus 1 is 3. Do you remember your calculus? So we have 4x3 dx. Since this constant here is just 0, the derivative of constant 6, any constant, is 0. So I do not write the plus 0 there. So our final answer, the derivative of this, is 4x cubed dx. Okay. If this is the derivative, let's now find its antiderivative. Okay, so once again we say that we take the antiderivative of this expression. Our answer must be this. Okay, we will go back to our initial function f of x, since the derivative and antiderivative is what? Opposite operation. Okay, so to take the antiderivative of the function f of x, so this is your function f of x, antiderivative of 4x cubed dx. This is now your integrand. And again, remember on our discussion last time, the rule is just we can always put the constant outside the integral, then remained with our x cubed dx here. Then what rule are we going to use in order for us to integrate this? Okay, remember again that according to our power rule, that variable u raised to some number n, which is our n here is 3, the derivative of this is just u, copy the u, and then n plus 1 all over the new exponent, which is n plus 1, or the new power, which is n plus 1. Then of course our plus constant c. Okay, if we apply this rule here now on our problem, then we have 4. Let us copy the 4. Then the integral of this x cubed is just x 3 plus 1, which is 4, all over the 3 plus 1, which is 4. Then plus constant c. Okay, so as you can see here, we can now cancel out this, because 4 over 4 is just 1. Then 1 times x to the 4th is just x to the 4th. So let's simplify this. We have x to the 4th plus c. That is now our final answer. Okay. So our final answer is x to the 4 plus c. Wherein our main function is x to the 4 plus 6, which is 6 is our constant there. So any function plus some constant there is equal to derivative. It is equal to the integral like this, x to the 4 plus some constant c, where our constant here is 6. So this 6 represents the constant c. All constant. Let's have another example. Say we have f of x is equal to, once again, 4x, x to the 4, x raised to 4, plus what if our constant is not 6? What if our constant now is negative 1/2? Okay. So the derivative of this is f prime of x, or f of x, is just 4x cubed minus 0 dx. Okay, just the same. We come up with the same answer, regardless of what will be the value of constant added to our another variable. Okay, so if it is minus 1/2 plus 1000 minus square root of 300, then we always come up with this derivative, since the derivative of any constant is just 0. Okay, so once again, if we want to know the derivative, the integral of this, then we can now apply the power rule, which is 4 times x to the 4 all over 4 plus some constant c. Then our final answer is just x to the 4 plus constant c. So once again, this constant here represents any constant that is available on your first function, or in your initial function. Okay, that's why in our main equation we always have this plus constant c there. Okay, so once again, if you want to check your answer in an integral, then you can perform derivative and vice versa. Okay, another example. Say we have we want to integrate x 6x 5 dx. Okay, so according to power rule, once again, we have 6x 5 plus 1 is 6 all over 6 plus c. Can cancel that out, so simply our final answer is x to the 6 plus c. Yan. Okay. And if you want to check your answer, then you can perform if derivative. The derivative of this is 6x 5 plus constant is just 0. Okay. So your do not forget d of x. So they are the same. Okay. So always, if you want to check your answer, your final answer in integral, you can do the differential. Okay. Once again, let's say we have r raised to 2 dr. Okay, so according to our power rule, so we need to add 1 to the r, to the exponent n. So we have 3 all over 3 plus c. This is our final answer. Then to check, you can perform derivative. So the derivative of this is f of r. The derivative of this is r squared all over 3 plus 0. So we can cancel that out, and then r squared dr. So this is now our answer. Okay. So that's all for the integral of the power formula. So once again, our power formula is just simply u raised to n plus 1 all over n plus 1 plus c. Okay? So always remember this formula. And then check your equation or check your integrand if we can apply this formula. Okay? So see you on our next video.